Hello, good morning, good afternoon, good evening, everyone. Welcome from wherever you're joining today. My name is Susan, and I am joined by Dexibit founder Angie Judge. Welcome, Angie.
Thanks, Susan. Great to be here.
Today we have a ton of tips and tricks to share with you when it comes to using SQL and Dexibit. We'll be covering off some basics that are really useful if you're just getting started with SQL. But to begin with, I'll take you through a quick intro to Dexibit for anyone that may be new here. So if you're new, we do data analytics specifically for visitor attractions. This is for both cultural and commercial organizations. And our goal is to democratize data. We do that by bringing together all sorts of data from around the visitor's experience in your venue's operations. So things like footfall, ticketing, CRM, point of sale, e-commerce, social web, weather, and so much more. I'll share my screen now to show you what that looks like in the product. So here is Dexibit. It is software as a service, so you can invite as many users as you'd like, and you can build dashboards, reports, insights, and forecasts, which you can then turn into scheduled email reports at a click of a button. In Dexibit, we have an extensive library of visualizations. To add one to your dashboard, you can simply search for the topic you're looking for and click Add to add it in. And this is an example dashboard, so you can see lots of different data coming together in these visualizations to get everything from very high-level data right down through to the very detailed data. And one of the ways we can get down to the very detailed data is by using SQL to filter for specific data points. I'll hand it over to Angie now, and perhaps, Angie, you can kick us off with an overview of what SQL is.
Sure. Thanks very much, Susan. Yeah, SQL or SQL, you might see it written as, stands for Structured Query Language. It is a programming language, essentially something that's used to manage data. It's been around since the 70s, very popular amongst data analysts. And at Dexibit, we use it in product along with a variation of SQL that we've developed called DxQL. That's a Dexibit's own query language, which is built off the back of SQL, and it contains some simplifications and some extensions as well to make it more applicable for the visitor attraction sector. So we might switch a little bit between both today. If you're a SQL expert and you see anything quirky, that's what's going on there. And so I will in turn share my screen and we will take a look in here behind the scenes. This is what Dexibit looks like, and there are two places in which we use SQL in here. And the first is a filter box. So that one here you'll see on the dashboard. And here you can enter in a SQL or DxQL expression. And this is something that's going to take your data that's in a visualization and filter it down. The second place is here in the Data Explorer. This is it here. And this is where you can enter in a SQL query, or again, use DxQL to actually extract data out of your data source that you're targeting. And you can also use it to create derived metrics, derived data sets as well. So for example, if I wanted to create a derived metric, again, I'm using a slightly different box in a slightly different place to enter in my query text here. So a few different spots where I'm using it. You'll notice here that this big statement here is slightly longer and more complex than what we might use in this statement here. And this is because in this filter box, we're just going for a little where statement versus in the big query box, we're doing an entire query here. So that's the difference between the two. So I wanted to run through a couple of interesting sort of examples, tips and tricks for those that are new to using a query language, and also perhaps a couple of things to pick up on if you've been using one for a while. And just to start us off, a couple of things that are useful to know about. The first is that you'll see a little dictionary icon here in the filter box, and that's a really helpful thing to be able to refer to. It will pull up for any data set that you're working on a list of all of the attributes that are in the data set, the descriptions of what those are, which can be controlled by you or us in the Data Explorer, and show you potentially some random data, sample data from within those attributes if it's appropriate. And this can be really helpful context when you're writing a query. So I often like to pull that up as I'm going. If I'm working in the main query box, and let's just blank that out just to make things a little bit simpler for us to look at. I can instead just open up this data set here, and I've got all of my different attributes, so that I can get into those and I can edit to have a look at details. So a similar way to kind of have that dictionary at hand as I'm going. The second thing is that you'll find that there are two purple references here in this filter box, a magic wand and kind of the reverse magic wand, which is what does this filter do? So on the magic wand side, you can enter in your own words here. So for example, I might like to say ratings over 5 stars, and I can click on this magic wand and it will convert my words into, oh, of course, there's no ratings over 5 stars, it's a bit silly. It will convert my words into a data query. So this is a really great way to get started with query languages, to give it something in your own words and just click on that magic wand. Now that magic wand again makes an appearance in the large query box, and again makes an appearance if you're doing something like a derived metric, you'll find it here. So it's in all sorts of places. If you don't know how to start, just write what you're trying to accomplish, click that magic wand, and it will find for you, it'll create for you a query to suit. The reverse of that, the what does this filter do button, will explain to you what's happening in this filter. So it uses, again, generative AI to take the query that's being used here and then to translate that back into easy to understand English. And here it's giving me a simple explanation. If I wanted to actually learn more, I can click on to do so, and it will sort of break that down for me. And that can be really useful if I'm looking at like a really long query. We're looking at a very simple example here. But if I was looking at a really long query, that would give me a good step-by-step explanation. This is a really great way, not only to understand what data we're looking at, but it's a really great way to be able to learn how to write in query language and kind of teach yourself. So if you're interested in sort of picking up the skills of a data analyst, do check that out. And this is a nice, easy entryway to get into using query language in this filter box, because I don't have to start by writing an entire query with select all from, etc., etc. I can just enter in what's called the where statement to filter the data. So just one part of that query. So again, it's just a simpler starting point for me to learn and play with using a query language. And this is kind of the idea behind Dexibit. By bringing this stuff to fore and everything else is handled, and also by using AI, sort of putting the skills of a data analyst in everybody's hands. I'm not a data analyst by any stretch of the imagination, but can do quite a lot with these sorts of tools, and particularly with the help of AI. So it's really helping democratize data that I don't need to refer to an expert to get at what I'm interested in. So let's have a look at some queries that we can use here in this filter box. So this data that I'm looking at here, just for context, is some Google reviews for my museum and precinct in Antarctica. You can see I've got lots of different locations here, and you can see this is sort of the typical data of what it looks like. I've got the location's name, I've got stars out of 5, I've got a review, I can see what channel that review was left on. There's also been a little bit of analysis here using generative AI. I can see sort of sentiment and topic. channel, prescribed response, etc. So there's a few different elements coming through here. So I'm interested in having a look at my different channels that I've got coming through. So the first thing that I might like to do, I've got a attribute here called channel, and we can see this if we have a look here at our channel data. I can see one of my channels here is survey. Now I want to say only show me, filter, only show me the data that's coming from the channel of survey. So I can say channel equals survey. Now, there are lots of different types of data fields. One of those data fields is a text box. And you'll see here in the data dictionary, I've got a little T next to some of these text box versus, for example, some of these other symbols that are, say, for example, show me this is a date timestamp, or this is a number here, for example. This is something called a Boolean flag. It's yes or it's no, it's true or it's false. And where I'm working with data in a text box, I always want to use a speech mark around it, an apostrophe around it, to indicate that I'm showing that that's the text that I'm looking for in that text box. And I'm using equals to say, show me where this field is exactly containing survey. And here you can see now I'm filtering down my data to only show me channel of survey. So all of these reviews here versus if I took that back out, here I'm seeing data from lots of different surveys, lots of different channels. Now, one thing you might notice about when you're using this equals to is that it's very particular. Like, for example, if I had a space bar here, I've got no data. If I, for example, had a small s rather than a capital S, I've got no data. So it's a very exact way of writing a query. Where I'm working with particularly text box, I like to be able to instead use the function of like, because at that point it's not going to be quite do the same job here, but it won't be quite so specific with being sensitive to case, for example. So if I use a small s, you can see now it doesn't really care. And I could even go as far as to use a % sign on either side of the word survey, because I could even make this look like, say, sir, for example. At that point, it's going to return me anything that looks like or contains SUR at some point. Now, this is not that helpful for this example, but we can imagine, for example, if I want to look at like review, comment, like food. So show me any review where the word food is mentioned at some point during the review. So a couple of things that are happening here. First of all, I'm using this function like, this one here. And secondly, to say that it can just contain that data. And secondly, I'm using this % sign here as a bit of a wild card to say anything with any text before the word food and anything with any text after the word food. Now, if I was doing something very particular, like I'm doing some complex queries with, say, some retail point of sale data, and I'm looking for like t-shirt sizes where it's like S, for example, is in the product name, and I might want to make sure that it's only S T, for example. I might like to use only a % sign on one side of the query rather than the other side, if that's kind of how the naming conventions are. So you can kind of get picky about where you're going to put those % signs. But in the case of what we're looking for here, where it's anything containing the word food, we'd put it on either side to say it can have text on before or after the word food and show us those data. So we can see here an example review. aquarium was decent, fish were cool, cafe food was meh. And so you'll notice as well that I did something else here when I was referring to this field review comment, and you can see some of these attributes that I've got available to me from this data set. They're called 2 words. You know, it's not just channel, it's sentiment emoji or management replied or rating stars. Wherever I'm referring to the name of a field, I then need to use an underscore between those 2 words. This is quite a common convention when you're writing in any kind of programmatic language, that you'll want to make sure that you're joining your titles together, and because that way when the computer is reading it, it knows this is part of the same thing and not 2 different things. And a couple of other things that can be helpful, and I like to often use the function of is null. So one of my fields that I've got in here is my management reply. So sometimes my team might be replying to these reviews, but sometimes they might not. So you can see here, here's my reply saying, thank you for your feedback. We'll be looking into this, versus this review up here doesn't have a reply. So I might like to filter and find where that field is empty. Where have my team not replied and the data is null? There's no data in those fields. So saying management reply, again, I've put an underscore between those 2 words because this is an attribute with 2 words in the title, and then is null. And this is to say there's nothing in this field, no data in this field. Or I can say is not null, and I can look at only things where my team have replied. So that's a really handy one, I find, particularly if I'm looking for example, I'm looking at zip codes. Show me ticketing data where the zip code is not null. So only show me data where I've got zip codes on my tickets. The other thing we can do is combine a couple of different query functions together. So for example, I might like to look at topics containing the word food, and also where the sentiment is negative. So we can see here, I've got, let's come back to topic. Here I've got all of my topics about food, and these are all the bad ones where customers are complaining or giving us negative feedback. And I can go a step further as well. Maybe I want to say topic like food or topic like drink, and sentiment is negative. Now, what I want to do in this case is put brackets around these 2 things. And if you think back to sort of high school maths, these are our operators which tell us which things should be true first in this little equation. So these things should be true first. I want to think about things that are about food or about drink, and they should also be negative. So I don't want to say topic is like food or topic is like drink and it's negative. I want to say topic is like food or topic is like drink, and it's got to be negative, if that makes sense. So you can use brackets, and you can nest your brackets as well to say these things should be true at the same time before the query moves on to another part of the operation. So those are a couple of quick tips that I like to use. Again, do rely heavily on this magic wand. And remember, it's not just there for turning your words into data queries. If you run into a problem and you're writing a data query and it's not coming out the way you hoped, or you wonder if there's a way to do it more efficiently, you can use the magic wand to do it. So you can type a query out, run into a problem, use the magic wand to clean it up. So coming into the big query box that we've got here, let's have a look at a couple of different things that we can do here. The first one that I love to know is select. And you'll notice this gets a bit easier in some ways here because it's coming up with little prompts of what to put in here as we type. So select means, get me this. And then I've got asterisk, which means everything. Select all my data from to say what data set I want. And I'm going to go Antarctic reviews demo. And I've probably got, I don't know, tens of thousands of data in here. So I might just limit it to, I don't know, 100 or so. And then I press play to run this query. So a slightly different user action. I don't just click out of the box for it to work. I press play for this query to run. And here we go. I've got all of my data, every single field from this data set. And I've got 100 of them down here, just as I've asked for 100 records. So this is quite a nice little statement to know. You can see here it's a little bit more complex than just entering a where statement. So a where statement fits into a select statement around here. So I might just say where review comment like food. You can see here when we were working with the little filter box, we were just entering this bit and the system was doing this and a lot more. Now, a cool little hack is you can actually copy the query out of a visualization and then you can just cut and paste it into here. You can see how long it is. We're going to use this little button here, which is just to format it. Makes it look nice, and let's actually just expand this out here so we can see how big it is. So again, I just, from my visualization, copied the query and I pasted it in here. And then to make it look pretty, I clicked on this little button to format it, which put it all on different lines just to spread it out nice and neatly. A lot of software engineers love their code to be properly sort of tabbed and spaced so that it's easy to read. You can see how much easier it becomes to digest. And here you can see how much of the querying the visualization is doing for us, like selecting the date ranges, for example, versus the little bit that we were entering in, which was this bit here. So super powerful to be able to, I think, like grab the beginnings of a query and then paste them in here and then use this as the basis to start working from. If we didn't want to go down the route of just describing what we're after in plain English and hitting the query button. And a couple of little hacks I like to use here is I like to say select distinct channel from Antarctic reviews. Let's run that and see what that does. Oh, nothing because I've spelled it wrong. Here we go. So what the function of distinct does is it says it gets every single data field from this attribute that's unique. So I have, I don't know, tens of thousands of rows of data in this data set. Some of them will be about surveys, some of them will be about Google, some of them will be from a compliment card. And what this function does is looks for all of the distinct items that are in channel. This is super useful if I'm wanting to like sort through my ticket product data, for example, show me every single ticket product I have in the list. And then I can start working from there to maybe simplify it or clean it up or look for anomalies and things like that. And so that's a really useful one to have. Another one is to pop in some time series. So we had a look at an example of this before. But for example, we might want to throw in something from like the month of May in 2023. So here I'm looking for reviews about fish that came in the month of May 2023. You can see here May 2023 coming up. So there's different ways in which you can refer to date ranges and date times in your query. So we saw one of them before when we copied across from a visualization. This is another example using a time series function at this point. So there are lots of these little functions in SQL where you can call upon them to do particular jobs for you, to be able to create different ways of looking at the data. So here we're saying looking at the months and calling out month number 5. And the other one that you might have seen me use just before is the limit one. So this is really handy if I just want a little sample and I'm looking at a really big data set. Oops. I've got my very specific equal sign on, so it's title sensitive here. And that is to limit to, say, 100 records or limit to, say, 10 records, for example. Let's run that again. So we can see here, this is just giving us a little sample, and this is really useful if I'm wanting to work really, really quickly. So I need my data to respond super fast, but at the same time, I'm working with a really large data set, so I don't want it to have to think about all of that. And then lastly, one thing to show you is that when I run a query like this, I can give it a name. And then I can click this button here to create a saved query, or if I've already got a saved query, I can then update it. So I'm going to click that one. And you can see here, it says that my query saved successfully. And it will appear, here we go, in my list of prior queries that I've got. Now, this is a really great way for me to save things to come back to, or save things for other people to use, so that I've got these queries stored somewhere and I don't have to sort of keep a document somewhere of common queries that I use. So this is a great way to be able to refer back to them super quickly. I can also turn them into a derived data set. Now, I might want to, in creating a derived data set, mix this up with other data from like weather data, for example. So I can say on this day, show me reviews on days that it was rainy versus days that it was sunny, for example, or filter it down or otherwise change up this data. And I can then create a new data set, which is just about what's in this query, and particularly if I'm mixing that together with something else. So those are my quick tips on using SQL and DxQL and Dexibit. So just to recap, there is those 3 places that we looked at. So the where box to filter data in the visualization, the query box to run a query here, and also we very briefly looked at the derived metric box to create transformations and derive metrics and other things. Here at an attribute level, all works exactly the same. Start off by looking at the magic wand or reversing out your query. Remember that great hack of copying your query across to run it, and then also that you can save things as well. Hope you had lots of fun doing that. I found it quite the learning adventure to be able to pick up a new skill, and the same for those out there that are passionate about data. SQL is a great skill to learn. Thanks, Susan.
Thanks, Angie. I've got a quick question before we go, and that is just when would you apply a filter in a visualization filter box versus when you would apply a transformation via a derived metric?
Oh, yeah, that's a really good one. I think a time when I'm looking to filter a visualization is when I'm just looking to get out of data, present it, for example. When I'm looking to use a derived metric, at this point, I'm looking to format my data for future use. So say, for example, with my reviews, I wanted to add something, so let's say topic is food, whether this review is about food or drink. And here I would then enter in my derived metric query. So we'd say something like review comment like food, or review comment like drink. And let's use a bit of AI to help me with that. So what I'm doing here is preparing an attribute that is going to always be present as an attribute that I can plot, slice, dice, filter itself by. So I'm preparing the data, versus if I was just doing this at a visualization level, I'm just viewing the data in that one moment, in that one way. And so this is really useful if this is something that I'm going to do routinely all the time, or if this is something that I want to dimension the data by for other use. So I want to use this in conjunction with something else. And so, for example, to group by ratings by is it food or is it not food, for example, and that's how I want the data to show on a graph. And so that's when I would sort of revert to doing the two of them. And I think and on one hand, derived metrics are amazing, and being able to put lots and lots in them is fantastic to open up the value and dimensionality of a data. On the other hand, I wouldn't go too nuts with them, because you kind of want to think about how you're going to structure, format, and keep that data set tidy for other people's use over time. If you do want to go really, really wild, I would almost consider creating a derived data set just for your own use, and then adding lots and lots and lots of things in there, versus like overwhelming a data set that's used by lots of different people, that you might like to keep a little bit simplified from there.
Awesome. Thank you so much, Angie. And thank you to everyone who's joined today. We look forward to catching you next time.
Thanks.